So, good morning, all of you. Myself, Professor Rakesh Patil from the Department of Civil Engineering, KLS VDIT Hyderabad. In today's class, we are going to study about the structural geology. What do you mean by structural geology? Structural geology is nothing but the study of the structures, rock structures, which are present inside the earth crust. These are the structures which develops the undulation or a cracks or a different terrains in the rock bodies. How does this happens? How does this happen? Due to deformation of a rocks. What do you mean by deformation of rocks? Deformation is nothing but a change in a shape and volume of the rocks. How does this changes occurs in the rocks? Due to different strain and different stress and strain. I think all of you know that what do you mean by stress and strain. Stress is nothing but the internal resistance offered by the rocks due to internal or external applied force is called as stress. What you do is take a one paper, then start applying the pressure on it from the both sides. What will happen? Either paper will bend or cracks will develop. The same situation, the same will happen inside the earth crust. Say for example, take a one rock layer, a horizontal rock layer, then start applying the force from the both of the side. What will happen? If rock have a sufficient strength, then what will happen? It will bend. Or else strength is not there, then what will happen? Cracks will develop there. So this is called as structural geology. Due to stress and strain, this particular rock attitude will changes. Rock attitude changes means the behavior of the rock will changes. Then what will happen? So stress is nothing but it's a internal. It is the internal resistance offered by the rock due to internal or external applied force is called as stress. In stress, there are two types of stresses are there: uniform stress and differential stress. I think you are studying this stress and strain in the SOM class also. In SOM class, what you are studying? You are studying for the specific materials. But here what will happen? Specific materials means for the beam, for the columns, or some other materials you are studying for the subject. But here what will happen? You will be studying this stress and strain for the entire rock masses. Entire rock masses means this structural geology deals with the minimum 2 to 3 kilometers, minimum 2 to 3 kilometers of a rock layer, which is present below the earth crust. Why we need to study this structural geology? The behavior of the rocks. Say for example, you are constructing anything on this particular rock layer, you should know the behavior. Say for example, after 2 to 3, after 20, 30 years, what may changes in that particular region. Say for example, if your stress is more in that particular region, what will happen? Again, the rock will bend. Again, the fractures, more fractures will develop there. So that's why this structural geology you are supposed to understand in before starting with your construction. Okay. So in stress, there are two types of stress are there: uniform stress and differential stress. Uniform stress is nothing but where the force acts equally in all the directions. Okay. Second one is differential stress. Differential stress is nothing but sir, differential stress. It is the stress is not which is not equally from all the sides. Then it's referred as differential stress. In this differential stress, we have three types of differential stress. That is compressional stress, tensional stress, and shear stress. Compressional stress, it is nothing but pushing pushing the rock masses. This is the stress which is squeeze the rocks. In tensional stress, what will happen? Pulling attitude will be there. This stress is which is stretch the rock masses. Shear stress means this stress is stress which is resultant in the slippage. Both rock gets slippage in that particular region. Then strain is nothing but strain is defined as a change in a dimension of a rocks due to force or a pressure. It is also called as deformation of a rocks. In strain, we have a different three types of development, that is brittle, ductile, and fracture. Understood? You can unmute yourself.
Yes, sir.
Yes, sir.
Yes, what we have discussed the deformation of a rock. Rock is a changes a size or a volume. Okay, in that stress and this deformation happens due to stress and strain. Okay, say for example, take a one notebook. Okay, then start applying stresses from the both side or forces from the both side. What will happen? What you will understand? In middle portion, you will be feeling you will be seeing one undulation, or else you will be seeing some fractures. That is called as deformation of a rocks. Due to this deformation of rocks, the structural geology means different structures may occur on that particular region. In stress, we have two types of stress: uniform stress and differential stress. In stress, we have three different development of a rocks, that is brittle, ductile, and fracture. Is it clear?
Yes, sir.
Okay. What I want is, you are supposed to examine this particular experiment right now only. Take a one notebook, all of you, take a one notebook. Are you doing this? Are you following
Yes,
me?
sir.
Yes, sir.
Okay, what you do is, take a one notebook. Okay, imagine that notebook as a rock masses, minimum 2 to 3 kilometer rock masses, that is. Just imagine, okay? Then what you do is, you just go on applying the stress there from the both side, both end to the notebook. Okay, what will happen? Can anyone answer me?
Bends, sir. It bends,
It
sir.
bends. Why it bends? Because the stress is equal in nature, or else the material which you are taking there, that has a capacity to bear your stress. If not, what will happen? If not, what will happen?
It will break, sir.
It will break. The cracks development will happen. According to that, in civil engineering, there are three major structures are there. One is folds, Folds means the development of a undulation. When it bends, bending means nothing but a folding. That is the first structure. Second structure is the joints. Cracks will happen, right? That is called as joints. What will happen after cracks? What will happen after cracks? The displacement of a rock mass will happen. That is called as faults. In civil engineering, there are three major structures are there. First one is fold, second one is joints, third one is faults. These are the natural structures which are present inside the earth crust. You can examine yourself only. Take one notebook, then apply a stress, okay, or a pressure. Then if your notebook has the capacity to bear the stress, it will bend, or else it will cracks will happen there. What will happen after cracks? Again, if you give a more stress, then the displacement happens. Displacement of a two different bodies happens there. That is the result of a structural geology in your civil engineering. If the bending is there, then it is called as folds. Only cracks are there, it is called as joints. Or else cracks are there with displacement, then it is called as faults. Is it clear?
Yes, sir.
Is it clear?
Yes, sir.
Okay. So this is how structural geology looks like. My slides are visible.
Yes, sir.
You can see here
Yes, sir.
bending. You can see here bendings. Okay. Just imagine on this bendings, if you don't study this structural geology, okay, the movement of the bend again happens after some years. So what will happen if you construct on this particular region? Again, the stress applies there, then this bend will get more fold there. Then what will happen? Whatever you will construct on this particular region, it may get collapsed there. That is the important to study this structural geology. In civil engineering, there are three major structures are there. First is fold, second is joint, third one is fault. Is it clear?
Yes, sir.
Okay. So what is structural geology? It's a study of factors such as origin, occurrence, classification, type, and effects of various secondary structures like fold, fault, joints in rock cleavages. And different from these are the different from primary structures like bending or a vesicular structure, which develops in a rock at the time of their occurrence. So before starting with the structures, I would like to just define two types, that is outcrops. Outcrop is nothing but it's a nothing but a rock exposure. Any geological formation exposed on the earth's surface is called as outcrops. Take a one rock, whatever the exposure is there, external feature is there, that external feature is called as outcrop. In outcrop, two different terminologies will be there. This terminology will be very helpful to understand the deposition of a rocks. Say for example, you are constructing a dam. That time this strike dip is very essential. That we will discuss in later classes. Strike means it's a horizontal line. Dip means a maximum angle of inclination. You can see here. This is a strike. According to this will be the dip direction. Yes, first we will study the folds. Folds are nothing but it is a undulation or a bending curvature developed in the rock stratas. See, this is how folds look like. Have you seen this kind of folds anywhere?
Yes, sir.
Yes. Have you seen this type of bends in your notebooks when I said to examine yourself?
Yes, sir.
ಯಾರು ಮಾಡಿಲ್ಲ ಇನ್ನೊಮ್ಮೆ ಮಾಡಿರ್ಬೇಕಾದ್ರೆ ನೋಡ್ರಿ. ಯಾವಾಗ ನೀವು ನೋಟ್ಬುಕ್ ತಗೋತಿರಲ್ಲ, just imagine that notebook as a one rock mass. Okay, then start applying pressure from your both the hands, from the both the end of the notebook. Okay, then what will happen, this kind of folds you will be observing in that particular region. Okay, now what I want is you keep anything on the notebook. Okay, take a one take your mobile only. Okay, then keep on your notebook. Okay, then apply a stress from the both end of the notebook. Okay, however you will bend your notebook, like that your mobile starts sliding from one end to another end. Just do it and tell me the result. Take your mobile, keep on your notebook, then apply a stress from the both end of the notebook. Applying the stress means applying the pressure. What will happen? Your mobile will start sliding, right?
Yes, sir.
Yes,
Yes,
that
sir.
is the result of the your structural geology. So what I am trying to tell you is, anything you will construct on the earth surface, say for example earth surface, then what will happen, if the more pressure area is there in that particular region, what will happen, whatever you will construct on that particular region, that will get start sliding from that particular region. Sliding is nothing but the collapsing. Have you observed it? Have you
Yes,
observed
sir.
it? Yes.
Yes, sir.
Okay.
Yes, sir.
Okay. Yes. In folds, there are two types of folds are there: anticline and syncline. If bending curvature is above the surface, then it is called as anticline. You can see in this diagram. Okay. If basins happens, means your bending goes downwards, then it is called as syncline. ಮಾಡ್ರಿ ಒಂದು ಸ್ವಲ್ಪ ಬುಕ್ ತಗೋರಿ. ಬುಕ್ ಮೇಲೆ ನೀವು ಪ್ರೆಷರ್ ಹಾಕ್ರಿ. ಪ್ರೆಷರ್ ಹಾಕಿದ್ಮೇಲೆ ಯಾವಾಗ ನಿಮ್ದು ಫೋಲ್ಡ್ ಮೇಲ್ಗಡೆ ಹೋಗ್ತದಲ್ಲ, ಅವ ಅದಕ್ಕೆ ಏನಂತಾರ, ಆಂಟಿಕ್ಲೈನ್ ಅಂತಾರ. ಅದ ಫೋಲ್ಡ್ ಕೆಳಗಡೆ ಫೋಲ್ಡ್ ಆಯ್ತು ಅಂತ ತಿಳ್ಕೋರಿ, then it is called as syncline. Have you done this? Have you observed it?
Yes, sir.
It is nothing but it depends upon the gravitational force. If gravitational force is more, then your bending will go upwards. If your gravitational force is low, then you will be having your force will go downwards. That is the result of anticline and syncline. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Here, classification of and types of folds. What I told you now, take a one book, just imagine these three layers as your books, then apply the force. The result will be like this: open fold and close folds. Next one is faults. Faults are nothing but it is a cracks or a fractures where displacement will be there. Okay, take your notebook. Okay, apply the force. Okay, then if applying force is more, what will happen, apply a force is more than your notebook pressure, notebook strength, then what will happen, first cracks will develop. Okay, okay, if your cracks, only cracks are there, then it is called as joints. But along with the cracks, if displacement means moving the blocks. Displacement means moving the blocks respect to your fractures, then it is called as faults. Here, this is how faults look like. Is this slides visible?
Yes, sir.
Okay, this is how what happens in faults. First, cracks will be there, then movement of a block will be there. You can see in this diagram, white band is there. In take a just example, a right side block and left side block. You can see in right side block, white portion, white rock is uplifted compared with left block. Is it clearly visible?
Yes, sir.
Okay. So what is this result? This result is a movement of a block. You can see here crack is there. Okay, only if crack is there, then it is called as joints. Along with the crack, if displacement is there, then it is called as faults. Is it clear, faults?
Yes, sir.
Okay. Now, joint and faults both are same only, but displacement will be there in the joints. Faults. Fault is defined as the cracks or a fracture along with there has been relative displacement of the blocks or a rock strata. The displacement of the beds along the fault line may be a meter or a several kilometer. The of the fault is measured in the terms of dip and strike. I told you dip and strike, right? Yes, here. You can see in this dip and strike. Is it clear? This measurement of the dip and strike, I will tell you in the next class. There are some problems are there that we will be solving in that. So magnitude of the faults. Magnitude means what? It's nothing but it's the measurement of the earthquakes. These are called as natural earthquakes. These faults are called as also a natural or a small earthquakes, because when blocks movement will be there, that time the vibration, sudden vibration may occur in that particular region. That's why it is called as natural disaster. Like fold fault also have a considered range in their magnitude. Some occurs for a short distance while others can be traced for a very long distance. In some cases, displacement may be less than a centimeter, while in other may be kilometer. The magnitude of a faulting obviously depends upon the intensity and the nature of shearing stress involved. When block movement will be there, I think all of you seen the landslides recently in Maharashtra. There is the major landslide happened. Have you seen that?
Yes, sir.
In Madikeri also.
Yes, sir.
In last
Yes, sir.
year, rainy season, in Madikeri, what happened? A block was movement was happened there. So these all are depends upon the faults. If fault is there, then automatically displacement will be there. Is it clear?
Yes, sir.
Now, parts of the faults. In a faults, we have anticline syncline. Here, we have a footwall and hanging wall. Footwall means which block is stayed stationary. Hanging wall means with respect to footwall, the movement of block will be there. That is called as hanging wall. Either it may go downward or it may go upward. Here you can see. Can you see this slide? In this is a left side, there is a hanging wall, sorry, foot wall. Right side, there is a hanging wall. This, whatever the displacement is called, that is whatever the displacement is seen, that is called as fault plane. So what you can see in this one, river is present here. So what river happened here? It is broken down. Is it clear?
Yes, sir.
Okay.